So please watch this video after watching the alkanes and alkenes. So this is about alcohols. Now the functional group, that's the thing that identifies alcohols, is the fact that it's got an OH attached to the rest of the alkane or alkene. They all end in ol because they're alcohols. And again, the first four members, just like before, are methanol, ethanol, propanol, and butanol. They all end in ol. They've got meth meaning 1, eth 2, prop 3, but 4, and that refers to the number of carbons. So let's try drawing these. So the methanol is the carbon covalently bonded to the OH group. Carbon has 4 bonds. So methanol would look like this. Ethanol, 2 carbons, covalently bonded to the OH functional group. There's ethanol. Propanol is 3 carbons. Again, make sure carbon has 4 bonds. And finally butanol. Look like this. Now you may see the alcohols look slightly different. You can kind of rearrange the atoms so it looks different, but it's still methanol or it's still ethanol. For example, instead of it just being OH, you could have the covalent bond to the O and then it actually showing the covalent bond to the H. It's still the same because you've still got the OH functional group. It's just showing here that oxygen's covalently bonded to the hydrogen, but we already know that if it looks like this. Now there are some other things you need to be aware of. Firstly, this is still ethanol. Okay. If you try and compare it to the first one we drew, the OH is just in a different position. That doesn't matter. You've still got 2 carbons, you've still got 1 functional group of OH, and you've still got hydrogens around it. The formula is still the same. You've still got 2 carbons, hydrogens, and then your OH group on the end. So the formula hasn't changed. And the same is true with propanol and butanol. Instead of having the OH group on the end carbon, you could actually find the OH group on the middle carbon. It's still the same, it's still propanol, it's just a different arrangement. So actually it looks a bit better to do this. So again, this is still the same OH group, it's just shown in a different arrangement, having the OH group in the middle carbon instead of having it on the end carbon like it is there. So now let's talk about some of the properties of alcohols. So the first property that we need to know is that they dissolve in water. For example, ethanol, to make an alcoholic drink, ethanol dissolves really well in water, and when it does dissolve, it forms a neutral solution. The next property of alcohols is they can be used for fuels because they can burn in air. I'll give you an example of that. So the example, if we take ethanol, so ethanol is C2H5OH. It's not a hydrocarbon because it's not only hydrogen and carbons, it's got an oxygen. If I burn it in air, called combustion, I add oxygen and it forms carbon dioxide and water. Now to balance this, you have got 6 hydrogens on this side and 2 there, so I need 3 there. Now balance my carbons. I've got 2 here So I want 2 carbons on this side. And finally my oxygens. I now have 4 oxygens here and 3 there, so I've got 7 oxygens on this side. I've got 1 here and 2 lots there. So if I put 3 lots of oxygen there, that then gives me 7 there. So this is a balanced equation for the combustion of ethanol. And you should be able to do this for all of them. The final property you need to know about alcohols is that they can react with sodium, and the gas that they produce is hydrogen. So if you react an alcohol plus sodium, one of the products you get is hydrogen gas. And so other things we need to know is their uses. So they're used as solvents. That means they can dissolve lots of things. So water's a good solvent, but there are some things water can't dissolve. So alcohols can dissolve some things. The other thing they're used for is they're used as fuels, because they can do this really well. They burn cleanly, and most of the time they're not smelly. On a future video, you'll look at how we actually get ethanol by a process called fermentation.